Welcome to exploration of basic mathematics. Trigonometry. Part 4. Trigonometric identities. Let us revise some basics. The triangle. A triangle is a closed-shaped figure in a plane, with 3 angles, 3 sides, and 3 vertices. Three vertices are A, B, C. The sides are AB, AC and BC. Angles are angle AE or angle CAB, angle B or angle ABC, angle C or angle ACB. The right-angled triangle. In a right-angled triangle, one angle is right angle. That is 90 degrees. Angle A and angle B are complementary, as angle A plus angle B equals 90 degrees. To draw a specific right-angled triangle, one must know at least one side of the triangle, along with angle A. Of 3 sides of a right-angled triangle, the opposite side to right angle is always the longest side, and it is called hypotenuse. Other 2 sides are opposite and adjacent to angle AE. Pythagoras' theorem. Draw a triangle with 3 sides as 3, 4, and 5. You notice it is a right-angled triangle. And also notice 3 square plus 4 square equals 5 square. With this observation, Pythagoras was first to state Pythagoras' theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. If A, B, and C are 3 sides of a right-angled triangle, with hypotenuse as C, then a square plus B square equals C square. The triangle with 3 sides known. Can we calculate values of angles? A right-angled triangle with one sides and one angle A. Can we calculate other sides? Trigonometrical ratios has the answer. Trigonometric ratios and functions. Trigonometrical ratios are sine, cosine and tangent. In short, we write them as sine, cos and tan. Sine A equals opposite, divided by hypotenuse. Cosine A equals adjacent, divided by hypotenuse. And tangent A equals opposite, divided by adjacent. With the help of sine, cosine and tangent, any side of the right-angled triangle, adjacent, opposite and hypotenuse can be calculated using following form. Opposite equals hypotenuse times sine. Adjacent equals hypotenuse times cos. Opposite equals adjacent times tan. There are 6 possible ratios and all are defined as opposite divided by hypotenuse is sine A. Adjacent divided by hypotenuse is cosine A. Opposite divided by adjacent is tan A. Adjacent divided by opposite is cot A. Other 2 ratios are defined as secant or secant, cosecant or cosec. It is also written as C in short form. Hypotenuse divided by adjacent is secant or sec A. Hypotenuse divided by opposite is cosecant or cosec A. Trigonometric function sine A is equals to opposite divided by hypotenuse. Please note here that the value of sine of angle A depends on the value of the angle A. As angle increases, so is the value of sine of the angle A. When angle A is nearing 90 degrees, the opposite side is nearly equals to the hypotenuse, and at angle A equals 90 degrees, the hypotenuse equals the opposite, and sine A equals 1. The maximum value of the sine is at 90 degrees, that is equals 1. As angle decreases, so is the value of sine of the angle A. When angle A is nearing 0 degrees, the opposite side is very small. And at angle A equals 0 degrees, the opposite equals 0. And sine of 0 equals 0. The minimum value of the sine is at 0 degrees, that is equals 0. Let's explore sine AE at a value of angle A equals 30 degrees. Draw a right-angled triangle ABC of angle A equals 30 degrees. Draw an arc at the point B of radius equals to A to locate a point D at hypotenuse AB. So the line segment DB equals BC equals A. Note: triangle BCD is an isosceles triangle. As side DB equals CB and angle DBC equals 60 degrees, angle BCD equals angle CDB equals 180 minus 60 by 2 is equal to 60. Or triangle BCD is an equilateral triangle. And sides DC equals BD equals CB equals A. Now focus on triangle ACD. Angle DAEC equals 30 degrees and angle AECD equals 30 degrees as angle DCB equals 60 degrees. It makes triangle AECD an isosceles triangle and line segment DAE equals CD equals LAE. So the hypotenuse AEB equals AED plus DB equals 2AE. Using Pythagoras' theorem, AEB square equals AEC square plus BC square, or 2AE square equals B square plus AE square, or B square equals 3AE square, or B equals under root 3 into AE. So the sine of 30 degrees equals 1 by 2. And sine of 60 degrees equals under root 3 by 2. Let's explore now sine of angle 45 degrees. Draw a right-angled triangle AEBC of angle A equals angle B equals 45 degrees and angle C equals 90 degrees and with sides AE, B, and C. As angle A equals angle B equals 45. Triangle AEBC is an isosceles triangle. Side AEC equals BC equals AE. Using Pythagoras' theorem, AE square plus B square equals C square, or AEB square equals AE square plus AE square, or AEB equals under root 2 times A. So the sine of 45 degrees equals 1 by under root 2. Trigonometric function. Cos A is equals to adjacent divided by hypotenuse. Please note here that the value of cosine of angle A depends on the value of the angle A. As angle increases, the value of cosine of the angle A decreases. When angle A is nearing 90 degrees, the adjacent side is very small. And at angle A equals 90 degrees, the adjacent side equals 0. And cosine 90 equals 0. As angle decreases, cosine increase. When angle A is nearing 0 degrees, the adjacent is nearly equal to hypotenuse. And at angle A equals 90 degrees, both are same. And cosine of 0 equals 1. So the cosine of 30 degrees equals under root 3 by 2. And cosine of 60 degrees equals 1 by 2. Note here, cosine of 45 degrees equals 1 by under root 2. Trigonometric function. Tan A is equals to opposite divided by adjacent. Please note here that the value of tan of angle A depends on the value of the angle A. As angle increases, so is the value of tan of the angle A. When angle A is nearing 90 degrees, the adjacent is very small. And at angle A equals 90 degrees, the adjacent is 0. And tan 90 is infinite, as this ratio is divided by adjacent, which is 0. As angle decreases, so is the value of tan of the angle A. When angle A is nearing 0 degrees, the opposite side is very small. And at angle A equals 9 degrees, the opposite equals 0. And tan of 0 equals 0. The value of the tan A is at 0 degrees, that is equals 0. Tan of 30 degrees equals 1 by under root 3. And tan of 60 degrees equals under root 3. Tan of 45 degrees equals 1. As sides opposite and adjacent are equal. Trigonometric function. Cot A is equals to adjacent divided by opposite. Cotangent or cot 60 degrees equals 1 by under root 3. And cotangent or cot 30 degrees equals under root 3. Cotangent or cot 45 degrees equals 1. Cotangent or cot 0 degrees is infinite. Cotangent or cot 90 degrees equals 0. Trigonometric function. Secant or sec A is equals to hypotenuse divided by adjacent. Note there is mistake here. Secant or sec 30 degrees equals 2 by under root 3. And sec 60 degrees equals 2. Secant sec 45 degrees equals under root 2. Sec 0 degrees is infinite. Sec 90 degrees equals 1. Trigonometric function. Cosecant or cosec A is equals to hypotenuse divided by opposite. Cosecant or cosec 30 degrees equals 2. And Cosecant or cosec 60 degrees equals 2 by under root 3. Cosec 45 degrees equals under root 2. Cosec 0 degrees is infinite. Cosec 90 degrees equals 1. Trigonometric identities. Ratio identities. There are 6 possible ratios and all are defined as opposite divided by hypotenuse equals sine A, adjacent divided by hypotenuse equals cos A, opposite divided by adjacent equals tan A, adjacent divided by opposite equals cot A. Other twos are hypotenuse divided by adjacent equals sec A, also sec A equals 1 by cos A, or cos A equals 1 by sec A. Hypotenuse divided by opposite equals cosec A, also cosec A equals 1 by sine A, or sine A equals 1 by cosec A. The sine-cosine ratios are sine A divided by cos A equals tan A, or tan A equals sine A by cos A. Cos A divided by sine A equals cot A, or cot A equals cos A by sine A. Pythagorean identities. Pythagoras' theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other two sides. AE square plus B square equals C square. Starting from AE square plus B square equals C square, divide the whole equation by C square. So it is a square by C square plus B square by C square equals C square by C square. Or a by C whole square plus B by C whole square equals 1. As A by C is sine A and B by C is cos A, so is sine square A plus cos square A equals 1. Starting from AE square plus B square equals C square, divide the whole equation by a square. Or 1 plus B by A whole square equals C by A whole square. As B by A is tan A and C by A is sec A. So 1 plus tan square A equals sec square A. Next identity we show here. Starting again from AE square plus B square equals C square. Divide the whole equation by b square. Or a by b whole square plus 1 equals c by b whole square. As a by b is cot A and c by b is cosec A. So it is cot square A plus 1 equals cosec square A. Pythagoras' identities are: sin square A plus cos square A equals 1. 1 plus tan square A equals sec square A. Cot square A plus 1 equals cosec square A. Reciprocal identities. These ratios are reciprocal to each other. Sin A equals 1 by cosec A. Cos A equals 1 by sec A. Tan A equals 1 by cot A. Or cosec A equals 1 by sin A. Sec A equals 1 by cos A. Cot A equals 1 by tan A. Check here these for angle of 30 degrees. Complementary angle identities. As defined earlier, the complementary angles are angles whose sum is 90 degrees. In right-angled triangle ABC, angles A and B are complementary angles. Note here, sin 30 equals cos 60, and sin 60 equals cos 30. As angles A and B are complementary angle, sin A equals cos B equals cos 90 minus A. So it is also true for cos A equals sin B equals sin 90 minus A. And for tan A equals cot B equals cot 90 minus A. And cot A equals tan B equals tan 90 minus A. All are summarized here. Sin A equals cos B equals cos 90 minus A. Cos A equals sin B equals sin 90 minus A. Tan A equals cot B equals cot 90 minus A. And cot A equals tan B equals tan 90 minus A. co-function identities. The complementary angles are angles whose sum is 90 degrees. In right-angled triangle ABC, angles A and B are complementary angles. As just seen, sine of A equals cosine of B. In cosine, the prefix co is for complementary. It means that the ratio of the angle is equal to the co-ratio of the complementary angle. Sine A equals A by C, which is co-ratio, for B or cos B. Same is true for tangent and cotangent. Tan A equals A by B, which is co-ratio for B or cot B. Now note it for secant and cosecant. Opposite angle identities. To learn these identities, we draw two opposite angles. Draw minus 60 degrees or 300 degrees and another 60 degrees. Compare triangle ADC and triangle ABC. Cos minus 60 equals AC by AD or equals 0.5. Or we can say cos minus 60 equals cos 60, which implies cos minus theta equals cos theta. Compare triangle ADC and triangle ABC. Sine minus 60 equals CD by AD or equals minus 0.87. Or we can say sine minus 60 equals minus sine 60, which implies sine minus theta equals minus sine theta. Compare triangle ADC and triangle ABC. Tan minus 60 equals CD by AC or equals minus 0.866 by 0.5. Or we can say tan minus 60 equals minus tan 60, which implies tan minus theta equals minus tan theta. Supplementary angle identities. Supplementary angles are when two angles adds up to 180 degrees or pi. To learn these identities, we draw two supplementary angles. Draw an angle of 120 degrees and 60 degrees. Compare triangle ABC and triangle ADE. Both triangles are congruent. Sine 120 equals DE by AD equals 0.87, which is same as sine of 60 degrees. Sine 120 equals sine 180 minus 60 equals sine 60, which implies sine of 180 minus x equals sine x. Cos 120 equals AE by AD equals minus 0.5, which is minus cosine of 60 degrees. Cos 120 equals cos 180 minus 60 equals minus cos 60, which implies cosine of 180 minus x equals minus cosine of x. Tan 120 equals DE by AE equals minus 1.732, which is equals minus tan 60 degrees. Tan 120 equals tan 180 minus 60 equals minus tan 60, which implies tan 180 minus x equals minus tan x. Supplementary angle identities are summarized here. Sine of 180 minus x equals sine of x. Cosine of 180 minus x equals minus cosine of x. Tan 180 minus x equals minus tan x. Variation of sine A and its curve. We know sine values for angle theta equals 0, 30, 45, 60 and 90. For angle theta is more than 90. U sine theta equals sin 180 minus theta. For angle theta is more than 180. U sine theta equals minus sine theta minus 180. For angle theta is more than 270. Sine theta equals sine 360 minus theta equals sine minus theta equals minus sine theta. Sine curve. Now we extend sine curve on linear scale for angles up to 180 degrees. Full sine curve on linear scale for angles 0 to 360. Variation of cosine A and its curve. Full cosine curve on linear scale for angles 0 to 360. Compare sine A and cosine A curves. Trigonometric periodicity is 2 pi. Note here that the value of sine only repeats after 360 degree, and we can write sine 2 pi plus theta equals sine theta, or sine 2 n pi plus theta equals sine theta. The periodic curves of sine and cosine beyond 360 degrees. Finally, we can say sine 2 n pi plus theta equals sine theta, cosine 2 n pi plus theta equals cosine theta, tan 2 n pi plus theta equals tan theta. Thanks for watching this video. Please continue to watch our other videos.